It's gonna be a short afternoon, largely because I'm frankly running out of material. We're going through this a bit faster than I expected to. So get out of here a bit early today. We'll do a little bit of rest tomorrow, and we'll call it good. So basically, what's going to be left for today is just quick discussion on versioning and locking. Right, you guys, anybody who's worked with databases before has probably heard of optimistic locking, right? Is that new to anybody? Yeah. Don't know what it. Okay. So we'll talk a little bit about optimistic locking and how you would do that. Turns out, I mean, very easy. It's sort of default behavior. And then we're going to tweak our schema a little bit more. Part of it is going to be schema tweaks. Part of it is going to be outside the schema. It's additional constraint validation. We'll implement our own validators, which are a standard Java EE thing actually, but this is a reasonable place to do it. Okay, so let's talk really quick about entity versioning. First of all, why would you care about versioning your entities? In other words, well, right, you know, what does that even mean? Oh God, it's so Thursday right now.
Legacy code support. Legacy code support.
Not for legacy. That's an interesting thought. That'd be like versioning your schema, right? But what about versioning individual entity objects? Well, let's just kind of go back to basics again. Like each entity object that we have in our system corresponds to what in the database? A table, or specifically a row in a table, right? Right. Each instance of an entity corresponds to a row, right? And so we're saying, basically have a version on each row. So what might that be useful for?
So if you update the entity, right? If you add fields or remove fields, and then when you create an instance, it will tell you what version of the entity it represents.
Oh, so that's an interesting idea. That's sort of like schema versioning again, so similar to what you were saying. But like you don't update your whole table all at once. You would have maybe some rows in the table would be on one version of the schema, some rows in the table would be on another version of the schema. That's an interesting idea.
So you want to know what was the last row that was added?
Last row that was added. Probably find that out from the row ID. Really, I think actually entity versioning, the only thing that it's good for is this sort of idea of locking. So let's talk about locking. Well, yeah. First of all, let's look at what it looks like in the schema. Right here, I'm going to open up. Let's say that I want all of my entities to be versioned. We'll see why in a little bit. So we have our base entity, and I can specify a private long version and say that it is a version, javax.persistence.version, right? So this is obviously going to be sort of a generated value, right? So let's say that all entities have a version, and we can probably, if we want to, we can have getters and setters here. Get version, set version. We don't usually want to update the version number by ourselves, right? We usually want the underlying system to do that for us. And let's, once again, run our code and see what, just see what we can see in the database. All right. So, right, we've got an ID and a version, and that's basically it. So everything has a version column, and that's all that it is. It's just an additional column. The database isn't necessarily doing anything for us here. Okay, let's do a little bit of debugging now. I should have run this in the debugger if I were smart, so that we can see what happens as we're editing and doing stuff with these entities. Let's do this. Where's all my code? There we go. All right. Let's do persons, for example. All right. Oops. So let's say we're editing persons and we're viewing persons. Right. All right. So let's add a new person. All right. Here we go. Okay. So we're trying to view a person right now, right? So we've hit our breakpoint in the debugger. Let's see. So the model is going to have. I always have to go through this and look at the actual table, right? It would be nice if we had a nice toString for our. Here we go. It'd be nice if we had a good toString for our entry here. Value person, address ID, name, version, and here we go. Version number is 0, right? And that's that's what we expect. We start with a version number of 0. So let's hit run, and we should be able to see also in the database log. Sorry, I know this is a little bit small, but you can see that that we've inserted. Yeah, this one, this version 0 here, right? Same for address, right? This is version 0 here for that address object. Okay, cool. Now let's do an edit. Oops. Let's do an edit. Oh, whoops. Sorry, this isn't where I wanted to break. I want to break in. Actually, no. In view. View is the only place that I need a breakpoint. All right. Edit. Here we go. So we've redirected to the view now, right? So the person should be updated. Maybe the address should be updated, right? I didn't actually change anything in the address, so we'll see whether Hibernate actually did something or not, right? So we should be able to go back and look at the value again. Here we go. Version is now updated to 1. The address, on the other hand, let's see. Yeah, the version of that address object is still 0 because we didn't make any changes to it. And again, if we look at the DB log, we should be able to see that that's reflected in here, right? Now, oddly enough, this isn't implemented as an update. It's implemented as a delete and an insert. Again, this is Hibernate being dumb, but well, point being, you can see that we've got version number 1, right? So anytime we do any modifications in the database to a versioned entity, the version number bumps, right? I mean, that's what you would expect. So I mean that's easy enough. We don't really have to do anything to support that. But what that's good for is again this thing called optimistic locking. Optimistic locking. I like. There's also something called pessimistic locking, just for completeness, I suppose. So this is going to get into sort of a side discussion about concurrency in general, right? We're trying to make sure that a transaction is really transactional, right? Is really atomic in some way. So what does it mean? What does it mean for something to be atomic? What does it mean for a series of operations to be atomic?
Either all of them execute or none of them.
Yeah, exactly. Either all of them execute or none. So in what what sort of thing might happen that would cause some things to execute but not all?
Out of sync.
Out of sync.
Conflicting resources.
Conflicts. Yeah, let's say maybe just exceptions.
Yeah.
Yeah. That's a simple example, right? Never mind concurrency for a moment. Let's just say that we have a transaction where you've made change A, B, and then you get an exception, so change C doesn't happen. Well, you want to roll back the changes to A and B, right? Okay. So again, let's just think about Java concurrency for a moment. Like how is that usually implemented just in pure Java? Like how would you make something atomic in Java?
Synchronized.
Yeah, synchronized block, right? And what does it do? What does a synchronized block do?
It will lock up the function.
Only one thread would be.
Thread lock.
Only one thread.
Right. It basically serializes. Well, all right. So we're talking about concurrency now, right? It says that only one thing, only one thread of execution can do these operations all at one time. We haven't said anything about what happens if there's a failure in between, but that's okay. What is it? This gets back to what Nipa was suggesting. What's another sort of failure? Like one simple failure is like there's an exception that's thrown in the middle. Well, another obvious failure is this concurrent case where we make a change to A and B or something, but then somebody else tries to also make a change to B. That invalidates the rest of our transaction. So synchronizing gives us an easy way of making sure that can't happen, right? Only one person can be doing things at once. The issue is that slows our application down quite a bit. Concurrency in that model is very expensive. So something that again, just talking about Java concurrency, right? Not talking about databases. Something that Java 5 offered for the first time was the Java util concurrent package, which has something called atomic references. Has anybody played with those atomic references in Java 5? What it lets you do, instead of locking, basically instead of having a synchronized block, what you do instead is you do a bunch of work, and then at the end of the day, you do in one atomic step, you compare your state with or basically you compare the state that you thought that you had, the state that you thought that you were working with, to the actual state that is right now. If the state that you thought that you were working with and the state that exists right now are the same, then you're safe. It means you can commit all the changes that you just made. If, however, somebody has done some work in the meantime, if your current state differs from the actual current state of the world, then it means that you got stepped on somehow, right? And that's what an atomic reference does in Java util concurrent, right? Well, optimistic locking is the exact same thing in the database world. It's our way of saying, hey, did somebody else do any work while we were? And that's what our version numbers are in support of, right? So, for example, let's say I have, person version 1, right? And I have some code that does, begin. This is just going to be pseudocode, right? Begin transaction. Person.name equals Daniel, I guess. End commit, or sorry, save person and end transaction. We can do a little bit of work here too. Person address is somewhere in Oakland, right? Yeah. I guess. Right. So we have one transaction that's trying to run like this. We have another transaction that maybe is actually doing the same thing, or maybe it's changing the name, changing the address, or whatever, and they're both trying to run at the same time. So let's say that the name was changed and the address wasn't, or something like that. So what would end up happening when our transaction ends and tries to commit? Well, what Hibernate is going to do is it's going to check the versions of all of the entities that are involved in the transaction. Perhaps this also involves multiple repositories even, right? It's going to check the versions of all of those entities, not necessarily the data, right? It doesn't have to compare the data as long as the versions are something that are trustworthy, right? So it'll compare the versions of all of these entities to the versions of those entities when the transaction started, right? And that's all it needs to do. If this person and this address are still at version 1, then the commit should be successful. If the versions have changed out from under us, then what's it going to do? Yeah, what's just a guess.
Revert it back.
Roll back.
Roll back. Well, I mean, it won't commit at all.
Commit fail.
Yeah, commit will fail. And how do you think? Just a guess again. How do you guess that Hibernate or the JPA would signal that failure to us?
Exception.
Yeah, something called an optimistic lock exception. You can tell a transaction to use pessimistic locking instead, but optimistic locking is usually a good idea, right? For performance reasons, right? We don't want to have to lock the whole database, right? That serializes everything on this one lock, which totally screws up our ability to do anything
So what happens if it's
concurrent.
like a row-level locking is supported in the database? Would Hibernate take care of that?
Yes, I believe Hibernate does know how to deal with that. Again, that's for pessimistic locking strategy, right? For optimistic locking, we don't lock the database at all. We just check our version numbers.
And how, if it is overwritten, right?
In other words, if there's concurrent modification.
Right. Then how is the rollback happening?
Well, Hibernate simply won't commit the transaction. Nothing happens to the database. Yeah. Yeah, we don't even go to the database at that
So
point.
it requires a commit facility in the database, which I think most databases have.
Yes. Yeah. So that's anyway.
So if you have two threads that are going to commit, is it going to throw an exception on the first thread that commits or the second?
The second one, because the first thread will commit successfully. Yeah.
So the thing is, the first one will have its data is not dependable, possibly, right?
Its data must be because all of its stuff committed atomically. The second one we can't be sure about, which is why we get that exception. So what do you do in that case? Well, catch the exception, do something with it, right? Maybe, and this again is sort of up to you guys. This is just basically, on a case by case basis. You would choose to either, let's say you're in your controller, right? So you could have your controller redirect to an error page. You could have your controller just retry. I mean, because maybe retrying is the correct thing to do, right? It's kind of it's like when you're writing code and somebody else is writing some code and you have a merge conflict. How do you deal with it? Well, I mean, sometimes you just trust the other guy. Sometimes you want to combine. Yeah. So kind of case by case basis. But that's that's really all I wanted to say about optimistic locking. Optimistic locking is the default behavior if you have versioned entities like this, right? Good. That's what it depends upon.
This is really the version management for each entity instance, right?
Yeah. Interestingly, this concurrency model inspired another basically a very similar concurrency model for application development in general. Something called software transactional memory. Have you guys ever heard of this? Is it software transactional memory, or STM?
Is it similar to that Linux kernel level running logs?
I have no idea. The idea of STM. So, I was just talking about basically Java concurrency, right? That was how I motivated this little discussion, right? Java concurrency, you just use synchronized blocks, and that, well, synchronized blocks kind of suck. I mean, first of all, because it's expensive to enter and exit a synchronized block. Second of all, because you're serializing what would have otherwise have been runnable in parallel. And third of all, is because your program doesn't compose. Like if you're thinking on sort of large scale software design, and you're trying to figure out how to organize all your synchronized blocks, how to organize your mutex locking, like you can't really reason very well about.
Does synchronization really work in Spring? Because you don't know whether it's creating a new object or.
You mean when you do dependency injection?
Yeah, I mean with dependency injection.
Oh, that's a whole nother story.
Because I haven't seen any synchronized code in Spring.
Yeah, for dependency injection, you don't need to worry about it because the container is doing it on its own.
It'll synchronize?
Yeah. It like basically the injection step is synchronized, I believe.
No. Once the object is created using dependency injection, right?
Mm-hmm.
You should be able to use synchronization methods reliably, or.
Oh yeah, I mean at that point it's just Java. Yeah.
So you said by default it's pessimistic locking, right?
By default it's optimistic.
Sorry, by default it's optimistic. But if you don't have this version, there's no way for him to know.
Right.
Database would be inconsistent.
It'll just be inconsistent.
Or there would be no exception thrown by.
Right. Anyway, so I was just saying that that this idea of committing a transaction atomically, there are now some interesting libraries and frameworks that are available for Java that let you treat objects in memory as versioned entities. So that way we don't have to have synchronized blocks at all anymore. We just say, okay, well, this stuff needed to happen atomically, so let's try it all. And if it didn't work, then we'll roll back those changes in memory.
Part of the Java code for Java library?
No, it's not. They're third-party libraries.
Is it meant to work with databases or?
No. STM is independent of databases. It takes this optimistic locking model and just applies it to memory. Right. This idea that thread shared memory is hard to deal with. So it says, okay, any thread shared memory should just be versioned as if it were a database. Yeah. So I mean that's not related to Spring or Hibernate, but I just thought it's a cool thing to talk about. Okay. Anyway, that's all that we need to do for that is just have a version attribute, and Hibernate takes care of it.
Since you're talking about versions, does Hibernate provide any way to manage the schema versions?
Oh, sort of. One thing that you probably noticed. Remember earlier in the week when we introduced Hibernate first. I wasn't doing a Maven clean every time I ran. We could do that now too, but as we were adding and changing things in our schema, Hibernate wasn't blowing everything away. It was doing like table modifications. So adding columns and so on.
Doesn't work or something, right? That's how it's
It won't. Yeah, it won't like remove columns for you. It's always happy to add stuff, but it doesn't want to blow your data away.
Sure.
Or I mean, at least the way that I have it set up. Remember, the way that I have it set up is to automatically update any new things, but not to delete.
Right.
Now, in terms of actually giving an explicit schema version number, Hibernate doesn't do that, but it does give you sort of hooks. So if you're it's sort of basically when your application starts up, you have the opportunity to look at the database and see what the schema version is. So you would just put your own table that has like one thing in it, which is the schema version. That's how it's normally done.
But I guess my question was more to say, let's say we have this the first version of entities, right? On the row, you change the entities, right?
Mm-hmm.
We're not talking about the instances, the definition of entity itself, right?
Mm-hmm.
You change the definition, either you add it, remove it, or something, right?
Right. Yeah, no, Hibernate doesn't, like what it's going to do for all of the things were already existing in there is just, they'll just have null columns, which might be a problem if they're supposed to be not null.
Right.
Yeah.
So it doesn't provide any sort of mechanism to deal with
Not easily, no. I mean, if you're doing a migration that requires some actual work, you have to do that work.
Okay.
Yeah. Yep. But the work that you conveniently don't have to do is still modifying any of the schema definitions. You just have to make sure to update your data.
Right.
Yeah.
But that has to be done sort of manually, right?
Yeah, that you have to do. Right. Yeah, it doesn't have any good guesses as to what you want there. Fortunately. Okay. So that's versioning and locking. What else do we want to talk about? Save. Okay. So let's talk. Since mentioned, for example, like a field shouldn't be null. Some field in the database shouldn't be null. Well, we want to be able to say that sort of stuff in our schema, right? That's if you're familiar with SQL, you can always say like some column name not null, right? Specify constraints like that, or foreign key constraints, right? We've seen those already. We also haven't seen, for example, all of our strings have been varchar 255s. We haven't seen any way to specify that those should be shorter or longer. Right, so we want to really start tweaking our schema to make us, to make use of our database fully. Right. So this turns out to be another very easy thing to do in JPA. All right. Let's say, for example, that yeah, let's find a good one. Office, yeah, that's fine. Right now, it is perfectly legal for an office to have null as a reference for an address. We don't have anything in our code that would insert null, but I mean, we could just, we could write some code that would say, office equals new office with a null name and a null address and a null company. And the database would be totally happy to accept that, right? Do you all believe me? Okay. Good. So let's say we don't want it to be able to have a null address. Let's say that we want this to to be a strict foreign key constraint, meaning this always references something. This must always reference an address. Right. So very simple. We say nullable equals false. Oops. Really? Hang on. Oh, sorry. For one-to-one mappings, it's called optional equals false. Yeah. Optional equals false. Optional equals false. Right. This relationship must exist, right? This office must reference an address. This office must reference a company. And then for simple columns, columns that don't reference some other table, it's called something else. It's called nullable. Right. So we want a non-null name column. Right. So let's try this. I'll rerun it again. We'll check out the database schema. DB log. Yep. All right. Okay, so we can see here, right? For company. Oh no, sorry. Office. Yeah. For office, we've got our ID, we've got our version, and we've got our name, and the names of our other things. They look just like name varchar 255, but now we've got name varchar 255 not null. Same with address ID, right? Address ID has to be not null, and company ID not null. Now, it is totally beyond me why in JPA they called this one optional for our entity relationships, and this one nullable for our simple columns. Why they chose different names for those, totally beyond me. But that's what it's called. So simple assignment for you guys, really quick, is just going to be to go through and find. Actually, you know what? Let's make this slightly more fun at least. Let's say we want to specify a maximum length for an office name. In other words, varchar 255 is arbitrary, right? What if we want the name of an office to be a maximum of 64 characters? what's the, yeah, length. All right, that's too easy, right? Length equals 64. Yeah, so that would be another way to do it. So anyway, yeah, quick assignment for you guys is just go and add some constraints like this. Whatever you think makes sense to your entities. And
how can we specify that a particular column, which is not the primary key, be indexed?
I think you don't. Let me, well, yeah. So there's a uniqueness constraint.
Yeah, so but that wouldn't make it.
That doesn't
Yeah,
that doesn't mean indexed though. Yeah.
How do you give default values? Default values by annotations.
That's a great question. To be honest, I'm not sure. Let's see if there's a default. No, that's not it. These are the wrong. Yeah. I've never seen that in SQL. Is that a thing?
Yeah.
Yeah. It shows what I know.
What was it?
Default.
Having
String name,
default
space,
values.
default space, whatever you want to give.
Yeah.
Yeah, in SQL, it's SQL. It's called default and value, right?
Default, yeah.
Yeah.
Default and value.
But you could make it a value defaulted here, but you don't have default in.
I can do it in Java, right? I can just give string name equal to San Jose.
There's no default parameters in Java, right?
Constructor. No, you can just give it right. Private string name equal to whatever.
Here, let's find out. I'm going to Google for it. Totally unembarrassed. JPA default value. Here we go. Hey, Stack Overflow. Oh. Okay.
Oh, yeah, it has to be in the definition.
All right. Well, this explains why I hadn't seen it. Is because it's terrible. Right. So if you want, you can specify it using SQL directly. This is so I'm a little bit dubious of this. Yeah. Yeah. This answer here that somebody was suggesting is that that once you've inserted, it'll have that value, but it's not part of the schema.
Yeah.
This is a Java style thing,
Yeah.
right? All right. So learn something new. Anyway, so go ahead and do some nullables, do some optionals, do some lengths. You could also maybe specify some orphan removals, but probably not important. And I'm just gonna go ahead and do this. How long should a street be? I don't know.
500. 255, I think.
Yeah, 255 is probably fine. Yeah. Zip, probably we can say length equals 64 or something. I don't know. Is it possible to specify that an ID is nullable or non-nullable? That wouldn't make sense, right?
Makes sense.
Right? Your primary key has to be there, otherwise you're sort of out of luck.
Then we seen log log that it was already saying not null.
Yeah, exactly. Yeah, it said that already. Version, we might, let's see. Yeah, it looks like you can't specify that. I think if you want to, you can also specify column, a column annotation on this one to say not null.
Would it conflict if you say nullable to true for the ID?
For ID.
Yeah.
Well, ID doesn't even have a nullable
Because
thing here. Yeah,
Oh, okay.
yeah. There's nothing we could do there. All right, company. All right, well, company doesn't have anything. It just says offices. So here's a question. This one-to-many relationship in offices. Sorry, a company.offices. Should we have that one be nullable or no?
No, it's not there.
It's not there. Yeah. If you say mapped by,
So if you have cascade all, orphan removal is irrelevant, right?
no, it's not included in this cascade all.
It's not.
Yeah, it's separate.
Well, I mean, whenever you delete one, the other would automatically get deleted. So you would, unless somebody is manually.
Oh yes, but well, basically this is a hint again to Java that says if I remove an office from this set, what that means is I should delete the office. Yeah. All right, so we don't need to do anything for company. Contact. Yeah, column. We definitely want that one to be not null. Office, we've already done. Person.
Should we have a name for a name?
Hmm?
In contact.
Some people have really long names. Yeah, I don't know. All right, address. Person definitely needs to have an address. Right. By the way, just back on that topic of orphan removal, what would it mean if we said orphan removal equal, or remove orphan or whatever it's called? What if we said that here? What if we said that here on person? What would that mean?
Would it be like a reverse?
Sort of.
Contact is removed.
It may not be relevant, right? That's the point.
Yeah, I mean it's actually sort of not relevant. Like if
Unless
like orphan removal, basically if optional were true, if this one-to-one map, if we could have a null address, what this would mean is that if I say person.address equals null, or person.setAddress null, and I save the person, the address object will be deleted. And now in this case it doesn't make sense because we've said that the relationship is mandatory. Right, we would have an integrity constraint violation. Yeah. All right, I think that's going to be pretty good. So let's stop and run. And see if we can get ourselves into an interesting state. All right, here we go. All right, so let's add a new person with no information at all. What? By the way, what do you think this is going to do? Throw an exception? You'd like that.
No,
but-
everything is
Yeah,
strings it's all strings, right?
yeah, it's just empty strings. Yeah, so that kind of sucks. All right, well, let's go back to the
Do
contact
that
list.
all in JavaScript. form.
Yeah. So, well, anyway, I mean, let's at least just go back and look at our log to make sure that those constraints appeared what we wanted them to be. Yeah. Name varchar 255 not null. Name varchar 64 not null. Yeah. So that's all good, right? So we're taking a little bit more control over our schema. That's good. Unfortunately, we're not doing any validation of what goes into the database aside from that. So you can see we've done this, insert into address values 1, 0, empty string, empty string, empty string, empty string.
Can you say empty string is not null?
Nope. Not in SQL. Not in SQL.
Null as a string.
Right. Yeah.
No, I meant to have an annotation, JP.
Yeah, so through annotations, we're going to have a different way of doing it. This doesn't get this won't be reflected in the schema, right? We don't have any way of expressing that particular constraint in the schema. Yeah, but we do have a way of doing it. So that'll get us to our next topic. Let me save this and commit it real quick here. Let's see. Huh? Weird. All right. So we'd really like to be able to prevent empty strings. JPA doesn't provide us a way of doing that, but there's a related standard, very closely related standard called Java validation, which does. So we're going to have a look at Java validation now, and I'll just do it by example first. Let's say that not only do we want this street column in address to be non-null, we also want it to be non-empty. So I'm going to specify not blank. Not blank. Okay. Let's take a closer look at this.
That's really close.
That was a joke. All right, I'm having fun. No. This is what we really want to look at, is the fact that this comes from Hibernate. This is actually not standard, this particular annotation. This comes from org.hibernate, which is going to get us into a little bit of trouble in a second. When we try to run, we need a quick update to Maven. Remember, we said in Maven that all of those things were runtime scope dependencies. So we can compile against them, but no, wait. Oh, sorry. No, wait a minute. How is this working? Did I really? Oh, Eclipse is a little bit confused. Yeah. If I try to actually compile this properly using Maven, and not using Eclipse, because Eclipse doesn't understand scope. If I try to compile this using Maven, it's going to complain that that org.hibernate stuff isn't actually in my class path. We get a build failure here, right? This package org.hibernate.validator.constraints, right? Because we said that it was in runtime scope. So what I'm going to do is just do a quick update to my POM, and you guys can do this too. Go to your pom.xml for the project, and just quickly you can just go to the XML view. Instead of saying runtime for the Hibernate validator, you can just say it's compile scope. So just quick configuration change. We're actually, this is the first time we're actually depending on a Hibernate specific API compile time, right? So far we've been depending just on JPA, which is which is standard Java EE. So we were getting it from the Java EE jar. But here, this is the first time that we actually need Hibernate validator in compile scope, right? So just quick change there. We ought to be able to compile this now. Building. Yeah, there we go.
Is there any impact to changing it from runtime to compile time besides being able to access that?
No, that's basically the only change. It's just the thing that we have to watch out for at that point is that we don't start introducing additional dependencies, right? You know, if we don't want to depend too heavily on Hibernate validator, we have to just like keep track of it ourselves. All right. So anyway, so we're using this not blank annotation, which comes from Hibernate, and we can apply this all over the place, right? Because that's what we like to do, is copy and paste everywhere, right? So an address has to have a street, city, state, and zip that are not blank. Real quick, we can look at, let's use Google for this. Org Hibernate validator constraints. Here we go. Here's some constraints. Some things that Hibernate decided to implement for you. These sort of an arbitrary set, but some of them might be useful for you, right? You know, the string has to be a well-formed email address, or a well-formed list of email addresses, or that you know we have a way of specifying a maximum length of a string. This also gives us a way of specifying a minimum length of a string. Not blank, not empty. Not empty is good for strings, but it's also good for collections, right? URL, right? Making sure that yeah. So this is a helpful way of preventing SQL injection, for example. You might implement validators that make sure that your input is well formed. Right?
There's no blanket SQL injection stripper, attack stripper.
A
Like
sanitizer.
you have that, right?
There may be. I haven't used such a thing.
Can
Because
you attach that like a filter to Hibernate itself?
well, I mean, what you end up doing is you just you mean that you just say apply it to everything, apply it to like all strings, all entities in the system? No, you have to do it individually.
So in PHP, you basically whatever SQL you construct,
Mhm.
just run it through this function, right? It will
Mhm.
automatically figure out if there's a problem with the SQL injection.
Cool.
I think you're
Yeah, I haven't seen anything like that. All right, so we've got some not blank annotations on address, which is great, and we can do the same thing for what? Well, let's see. Set of offices. I'm tempted to say that a company should have a non-empty list of offices, but that's not true because we start out empty. Contact. Yeah, that should not be blank. That should definitely not be blank. Blank. Right, we're basically saying that all of our strings should not be blank. Right? So now, if I rerun this, we're going to see some interesting stuff. All right, let's add a new person, and let's try to have the person with some blank stuff, right? Try to do add now, and here we go. We get an exception. So again, runtime. Everything is all runtime exceptions, but But some interesting things to notice here. First thing to notice is that the work that we just did all falls under the blanket of javax.validation. Right? Like I said, this isn't like all of our JPA stuff was in javax.persistence. This is in javax.validation, which is a different standard, but it's related. Right? Basically, it says anytime you're working with database, or basically anything that can hook into validation. So databases is one such example. We will run validators for each of the annotated things. We're going to see what we'll finish off today with is actually implementing our own validator. But anyway, point being, just this is yet another one of these related Java EE standards. Thing number 2 to notice is that it doesn't give up after the first validation failure. It checks all of them, which is a very nice thing. Right? Probably one of the most annoying user interface issues I've ever seen is the thing where, like, you've got a list of fields that you need to fill out, and you filled several of them out incorrectly, except for it only tells you one of them at a time. So you resubmit and it tells you the next thing that's wrong. You resubmit, it tells you the next thing that's wrong, and so on. So when you catch a constraint violation exception, that constraint violation exception has an array, or a list of all the constraint violations. So you can display them all at once. That's a very good thing, right?
How does it implement this?
Again, reflection. And we'll see how to hook into this.
If you check the database, check the database.
Sure.
The schema.
We shouldn't see anything interesting in the schema.
It's only added not null for all of them.
Yes.
And if you make it to nullable equal to false, it'll also add the same thing. Instead of add not blank, just put nullable equal to false. So the schema doesn't change.
That's right. This not blank thing doesn't have anything to do with the database schema.
It adds not null, at least. So if you check.
It shouldn't.
Yeah, it is adding. Go to the address.
I'd be horribly surprised. So if I take these out, you're saying?
Oh, they're there. Yeah, I think it is adding.
I'd be very surprised, but let's see. Yeah, if I take these nullable equals false out and rerun, I'll be very surprised if we see a not null in the schema. For address. Yeah. What? What? Holy crap, are you kidding me?
So there's no difference. I don't know how very difference.
That's interesting. That's really interesting. It may be because it's a Hibernate annotation, so Hibernate still knows some special things. That's cool. Yeah, see, wait, really? Huh. All right. Well, I don't know. I think it's a better idea to use the JPA standard stuff anyway, even if it's redundant. Not blank. Basically, I would say, like, my rule of thumb would be treat all of your validations as though they're runtime only, as though they have no effect on your schema. Like I said, I'm extraordinarily surprised that that Hibernate actually took this and did something in the schema with it. Huh. Very curious, but okay. All right. So, I guess we can jump directly into. Well, here, let me check this in. let's think of some things that we would want to validate about our data. Like some properties of our data that you know, again, that we can't really specify in the database level, but that we would want at the application level, the application layer to make sure are invariant.
Zips, zip code.
Yeah, zip codes. Okay, that's a good idea. It's a good idea. Let's make a list. Validators. Zip code. All right. So that's a validator for a property, right? We want the value to look like a certain format, right? We can even go higher level though. Like let's try to think about some relationships between our entities.
Constraint like a person can only have 3 addresses maximum, something like that.
Or yeah, maybe yeah, a company can only have. Although Hibernate actually already gives us that one, I think. Is that right?
Or the
Length.
or
Actually, you know what? This is only for strings, I think. Yeah, that one's only for strength. Here, let me double check. Yes. Yeah, unfortunately, that one's only for strings. So yeah, we could create our own thing that says the list of addresses for the list of offices for a company, right? A company can only have you know, maximum of 5 offices or something. Yeah, so we could do something like that. Something like that. Or you know, to generalize, collection length. Right. All right. We don't have all that many interesting relationships in our code yet, and so I was going to give you some work that you know, some of it is going to be just sort of repeat effort from before. Not repeat exactly, but you know, just be sort of reinforcing some of the stuff that we've learned. I was going to suggest that maybe a person should actually, you know, since we've got like people and companies, that maybe a person should have a manager and should have an employer, right? Because then we can make sure that, you know, a person is not their own boss. You know, you know, basically just kind of like adding some data to our schema here to just make it a little bit more interesting. So a person should not be their own manager, or you know, maybe like a person's manager shouldn't be, you know, management cycles shouldn't be like should be acyclic, right? Management structures be acyclic, or
That would be interesting.
yeah, or you know, if person A works for a you know, yeah, basically if you got person A and person B, and you know they're you know, person B is person A's manager, then they should both work for the same company, right? So I'm going to give you some work. We're not going to implement validators just yet, but you know, this will be sort of work along the lines of what we've been doing before, just kind of more practice, right? So your assignment, or here, let's something like that, right? So assignment, and this is going to be basically sort of a combination of everything that you've learned so far, right? Everything about sort of Spring, everything about you know, everything that we've done so far with JSPs and so forth, and Hibernate as well. You're going to say, person, add manager and employer to person. So a manager is a person, and an employer is a company to the person entity. And in the, so show manager and employer in the person view, right? Show the manager and the employer. And in the edit view, we want a drop-down list, and this is similar to what you were thinking of before for how we do offices. We want a drop-down list to choose manager and employer. Right. So that's going to be your assignment for now. This will take maybe half hour or something, and then that'll give us enough interesting stuff to work with for validation. Okay. Let's take care of the JSPs, because that's again that'll sort of tell us what our models need and all that kind of stuff, right? So for a person, what do we need? For the person view, what do we need?
Employer.
Company name.
Yeah, just person dot employer
Employer.name.
dot name. Yeah, so let's do manager first. Manager person dot manager dot name. Right. Right. This is what we'd like to enable. So that means that person is going to need to have a manager and an employer, right? That's what that relationship is going to need to look like. It's at some level. And then how about for edit? What do we edit's going to be the fun one. We're going to need a drop down list for whatever reason I really like lowercase. All right. Manager and employer. So hands up who remembers HTML well enough to know how to do drop-down lists.
Is it like a text field with some attributes?
I think it's
Selection.
Select inside options. Select option.
Yeah. So select name equals manager ID. Probably we're gonna have a drop down list of manager IDs.
Manager names.
The values will be ID.
Yeah. So exactly the values of the options that are in here are gonna need to be IDs so that we can use them. So it's gonna look and each of these things are gonna be options, right? So the first one that we need is none, right? Right. No manager.
May not have manager.
Right. Yeah. None.
No, this is the edit field, right?
Mm-hmm.
We should be providing the value, right? What if you already
Look up
have
and provide the value.
default?
All right. So we're gonna need to we're building a drop down, right? So for each. Yeah. So we always need an option for no manager, but we also need options for all of the people in the system.
I think if the current manager should be selected.
Automatically select.
Oh yes. Yeah.
Default.
We should support that. Right. We'll do that inside here. So for each, what?
Person dot. For each person.
For each var manager, I guess, you know, I'll just call it manager. These are our possible managers. And what's this gonna come from?
Person not manager.
Mm, no, we need a list of all the people in the system to choose from as managers. So we're gonna pass a new item in the model. So for each manager and managers, we need yeah. All right, but we want one to be selected by default. Like if the employee has a manager right now, we want it to be selected by default. So not loop again. We need to actually have an if statement, except for the goofy way that we need to have like if else is choose in yeah. So this is the way to do mutually exclusive conditions in JSP. So we choose when let's see, manager dot I or yeah.
Question dot manager.
Yeah. Or, I mean, the easiest thing to do is actually just do it like this. JSP will figure out figure out what we mean by that. Otherwise, yeah, when and otherwise. That's what it's called. It looks a lot like XSLT, unfortunately. All right. So this is going to be our otherwise, and our one that where it's selected. We have to say selected. Just selected like that is okay. Yeah. So, right, JSP. And we're going to want to do the same thing for employer, right? Right. All right. Okay. All right. And so that's how this edit page is going to look. Let's, well, so if we try to run this, it's probably going to blow up on us because we haven't actually added any fields yet. We haven't actually added the manager or the employer field to the person class. So let's verify that it does blow up the way we expect, at least. All right, new person. So this is the add field, right? Add. We haven't done anything, but here we go. All right, so we can't view the person because person does not have the property manager, right? This is when we're trying to parse out our JSP EL. Okay, so that brings us to person. What does person need to have? All right, well, obviously, private person manager, private company employer, and we will generate getters and setters just like we always do. But what should these columns look like?
Many to one.
Yeah, many to one. How many of you guys had that? How did you specify the relationship in your code? You had many to one. What did you guys
I
have?
was trying to do one to many, but it couldn't.
Oh, the other way around in yeah. Well, so in person you can have like like manager could be reports, and so we could have
Subordinates.
Subordinates or whatever, and you could have one to many that way.
Yeah, that's what I was trying to do.
Yeah. Doing it that way, we would have a join column, which is really weird. It'd be a person join column.
Yeah. Oh, I see.
Yeah. So yeah, many to one. That's fine. What do we think about optional?
Based on JSP, it could be optional.
Yeah, optional equals true, right? Not every person has a manager. So we could say optional equals true, or that's the default, right? So just leave it blank. How about cascades?
No.
No cascades. Yeah,
Never aspects.
yeah. Changes to a person should not cause their manager to be updated. Right? We don't think of the ownership as going that direction. So I think many to one, just like that, is fine. How about employer?
And do one.
Yes. Many to one. Right. Many persons will have the same employer. Now, if we wanted to, we could do just like we did with offices and, excuse me, we could do just like we did with offices and companies, right? We could have an inverse, private, set of person reports, and we could have a one to many mapped by a. Mapped by manager.
If we don't have this, we expect another table, right?
If we don't have mapped by, then yes, we expect another table. We expect that join table, right? So we could do that. We could do that. I'm not going to, but you can. Again, same thing with company, right? You can have a set of employees in the company. I'm not going to make you go and do that work because it's not really the point right now. We want to get into validation as soon as we can. Okay, so hopefully if we
Company side, you don't have to do anything. Set of employees. Set of employees that a company has.
if you wanted to, you could do some more work to in the company view, you could display all the employees. Yeah, if you want to.
So for one-to-many relationship, the set is not important, right? The set that we have, right, in a one-to-many relationship.
Oh, you mean the other side, the
The one side will have a set, right?
Yeah, the one side will have a set. The
It's
many
not
side.
mandatory. It is mandatory, right?
No, we don't have to do that other side. We can just have this side and it's fine.
What does that give us? The set. It gives us the list, right? How they're mapped for a given ID to many.
I don't follow.
So we have a list of. A company has many offices, right?
A company has many offices,
So-
and we set it that way, like we wanted to sort of set it up that way because we say that a company owns its offices.
Yeah, but we had a Java set, right? On
Yes.
the many side, on the one side. A
Yeah.
set of
Yes.
that will have a collection, right?
Mhm.
That's not mandatory for a one-to-many relationship. I thought that was always needed, right? How else would he know that these are the sets associated?
Well, it'd be a set or a list or some
Yeah,
kind
something
of
like that.
collection. Yeah.
For this
So
we
so
don't
so
have-
so if we wanted, right, if we wanted to have the inverse of this, then that's exactly how we would do it. We would do it with a set or a list or
What
whatever.
about the second one? The company employee.
Same thing, right? if we wanted to be able to see all the employees of a company, we would have a field in the company class that was a set of persons, and we would say mapped by employer.
So Hibernate automatically fills up that set.
Yes. Yeah, when it loads
Whenever it
it.
does a setup.
And it fills up that set by joining with this, right? Because this is where it actually lives in the DB. Right? It lives on the many to one side.
It is on the menu side.
Right. Okay. All right. So hopefully, there we go. All right. So we have manager. Well, manager is nothing, and employer is nothing right now, but that's what we expect, right? If we look in the DB log, we should see some nulls, and again, that's what we will expect. Yeah. Right. So we've inserted a person with two, with a null manager and a null employer. Right. Okay. Let me check this in for you guys. Oh man, I stopped it running. I wanted to verify that the drop-down lists. Yeah. Whatever. I'm sure they work. No, I'm not sure they work. Where are we? Yeah, let me make absolutely sure that they work.
The person can be his own manager now.
Oh wait, no, they won't work because we haven't.
Managers, we haven't appended.
We haven't. We haven't set those properties in the model. Yeah. So fine. So we won't work, and we just expect that. Let me check this in. So. All right. So that is now checked in for your convenience. Yeah, who cares? Okay, so so now just the last step is to fill in the controller, right? The person controller. So go ahead and do that. All right, and how do you get a list of all of the the employers? Yeah. Or I should say, like, what did we say needed to be in the model for the edit person view?
You have to provide managers.
All the managers.
All the managers and
all the employees. Employer.
And all the employees, yeah, all the companies, yeah. So basically, we need the person repository, and we need the company repository as well. Now I actually can't remember. I need to look at something in my own README very quickly because I want to know if you can inject the. I want to know if you can inject any bean. Let's see. No, looks like no. Request part entity map. Yeah, it looks like I can't. That's fine though. Let's see. Yeah, it should be fine. Sorry?
We haven't changed the view. Have we?
Uh,
View for the person?
For view person, yeah, we haven't changed the model. For edit person, we have, right? For edit
The tool
person,
hasn't- even the tool hasn't changed. Only the edit and
yeah, only edit.
only
Yeah. Right. So that's all of our managers is the person repository.find all, right?
employee.
Sorry.
Find out, really?
Really?
The managers, I mean, you put in every employee there,
Yeah, basically we're just going to say that we're,
simplifying it.
yeah, we're just going to say let's put a drop down list of all people in the system.
Oh, I see.
Which, you know, obviously this is going to be terrible UI if we.
Otherwise, we'd have to probably have another field whether it's a manager or not, right? Like a Boolean or something.
Oh, something like that. Yeah, yeah. But yeah, this is basically just like, you know, any person could possibly be a manager. Any company could serve as an employee. Well, that's a little bit more plausible, I guess. Certain people you just really don't want to be managers. All right. Then what was the other to do here?
Post-edit person?
Yeah, and post edit person. So we need yet another couple of parameters here, right? Request param.
Manager ID?
Yeah. What type?
Manager underscore.
Long.
Long.
Long. Yeah.
And company ID.
And I'll do this.
Manager underscore ID.
I'll do it like this, just to kind of be nice. And right. So person dot set manager person repository dot find one manager ID, right? And person dot set employer company repository dot find one employer ID. Yeah. Now, since we're starting to get a little bit more sophisticated here, since this operation is no longer just one query, it might be reasonable to make this transactional. Yeah. Transactional. You know, I don't think we'll have any problems with this one way or the other because, you know, because it's just us playing around. But, you know, I mean, I think it's not a bad idea.
In this master, we are only really saving the person in the end. So really, one write operation to the database, right?
Yeah, it's only one write operation of the DB, but we do want to make sure that the manager that we found here still exists in the DB down here.
Yeah.
You can see there's a little. You see this little icon here. This is Spring, the Spring tool suite saying, hey, there's some AOP going on here.
I don't see it in my environment.
You might. So I actually needed to re-import my project at one point to make sure that Eclipse noticed that it was Spring. Like, do you have these like S's on here?
No.
Yeah. Yeah. So you need to have the Spring nature on this project.
How to do that?
I just re-imported it.
Oh, okay.
Oh, we imported and that's it?
Anyway, yeah. So advised by the transaction interceptor. Right.
Did you need to re-import it to enable the transaction?
Not to enable transaction. It's just to make Eclipse notice that this is a Spring project. just so that it can show me these little hints and stuff. It hasn't been very useful to me so far, but I just thought I'd point it out here. Yeah, okay. So I think that should be okay. Let's give it a shot. Then we'll take a quick break and we'll do our validation annotation. Let's go back over here, back to contact list. All right, so let's add a new person, Tesla. I'm totally going to be Tesla's manager. So I guess I need to go back to the contact list and add Dan. All right, so we've got Tesla, we got Dan. Tesla's my dog, so let's edit this person. So here we go. We've got manager choices. Well, we shouldn't. Yeah, I mean, if we were really good, we would just not have Tesla in the list. But we'll keep it like that because it'll give us some nice stuff to use in our validation, right? Well, anyway, so we can choose Dan. We don't have any employers in our system right now, so let's just save that. Here we go. Tesla's manager is Dan. If we edit this guy, we can see that our JSP stuff worked, right? We can see that Dan was selected by default. So that's good. All right, me and my dog. Man, I'm not going to see my dog until Monday. I'm going on a camping trip until then. I miss my dog. Okay, anyway. So that stuff worked, right? We've got what we needed. And this turned out, I mean, basically once we had all of our plumbing set up, all of our Hibernate and Spring plumbing, like this turned out to be pretty easy, right? Like this wasn't actually all that much work. Which, I guess is sort of the point, right? We've seen how you can run into problems with Hibernate some of the time, but a lot of the time Hibernate really does make it easier for you to do this stuff, right? We made some very simple changes to our schema. We didn't need to really do anything to support that. We updated our views, we updated our logic, and we were good to go. That took what, half hour, maybe 20 minutes. If we were just writing the code, it'd take us like just a few minutes. So let me check this in. Let's take a break. I sort of assuming you don't have any questions on this yet, right? Because this is stuff we've basically done, right? Okay, so let's take a quick break. Let's come back at 4. Start up again pretty quick, and then we can get into data validation. Yeah, writing our own. I mean, we've seen a couple of ready-made off-the-shelf validators, but want to make our own.